That was like a dream come true. Eye of the tiger. Okay, well, as you know, my name is, oh, I need a little clicker here. My name is Alexander Pope. I'm super, super excited to be here. Really honored that I was invited to come all the way from frozen Norway to visit beautiful Melbourne to tell you this story. Now, it's a scary story, and like the best scary stories, it's all true, mostly. Now, as you know, this is called OUTBREAK. Index-SW-9A4C-B4B4-778 E7D1 CA619 EAA F5 AC1 DB.js. The year is 2016, and in the corner of a functional, though charmless, open office, Alexander sits at a desk staring intently at the screen. A phone rings in the background, momentarily disrupting the early morning stillness.
Hey, wow, you can import analytics data into Can I Use? And it looks like we already have over 50% ServiceWorker support.
Alexander, it's still considered experimental. The specification has not yet stabilized.
Nah, that's all they were talking about at Google I/O. ServiceWorker is the best thing since Ajax, and it's already huge in India.
Be not the first by whom the new are tried, nor yet the last to lay the old aside.
The following morning, in a cramped meeting room, Alexander enthusiastically sketches on a wall-mounted whiteboard.
This is great! It's basically a proxy server in your browser. You just call Navigator, ServiceWorker, register with a path to your script. It returns a promise, so that's cool.
Alexander, I hope you are aware that the ServiceWorker lifecycle is non-trivial. There are many opportunities for error.
No. This is the web. If something is broken, you fix it and ship it. Continuous delivery for the win. At Google I/O, they recommended you just change something. The ServiceWorker will be invalidated and reinstalled. Eventually, anyway. Within 24 hours, at least.
Fools rush in where angels fear to tread.
Days later, Alexander hurries to clean up commits while rebasing a git merge in time for release. The desk is littered with disposable coffee cups.
Embed unique asset names. Add feature flag. Use cache first strategy. Add cache expiry logic. Cache all API JSON data. Add app shell. Add online, offline status messages. Remotely log errors.
Alexander, haven't you forgotten something? What about testing?
Testing ServiceWorker is hard. So many globals. And that installation lifecycle. Things are working fine locally. And anyway, it's progressive enhancement.
The most positive men are the most credulous.
Several weeks pass. In the quiet of a darkened living room, Alexander anxiously scans error logs. Notification alerts pierce the silence.
Type error? Undefined is not a function. Not a function? How could I at ServiceWorker global scope.o not be a function? What the hell is going on? I don't get it. Things have been running smoothly for weeks. The only change here is some refactoring. How could cache add all be undefined? It works fine on my machine.
Versions of Chrome prior to 46 did not ship with cache.add-all, among other differences. The specification is still unstable, as you are well aware.
Shut up. You are not helping. I need to focus while I revert these changes.
1 week later, back at the office, Alexander puzzles over the latest error logs.
That's weird. It's been almost a week since I reverted those changes, but there are still lots of errors. It shouldn't take that long to upgrade. It's just not possible.
The logs say otherwise. There have been more than 2,000 errors reported in the last 24 hours alone.
More weeks pass. Visibly tired and distraught, Alexander slumps over his computer at the dinner table. A baby cries in the background.
This is starting to freak me out. I don't understand how there can still be so many errors. And it looks like they're coming from inside the house.
Alexander, don't be ridiculous. The errors are clearly not coming from inside the house.
Is it me? Are they inside me? Am I infected with these errors?
No, Alexander, you are not infected. It would appear that, for a small number of clients, index-SW-984C43B4B4778E70D1CA619EAF5AC1DB.js has been permanently installed.
What, permanently? It can never be upgraded? Like some kind of dead zombie service worker?
That is correct. You fucked up. You fucked up big time.
I told you it was a scary story. There's something strangely compelling about a disaster story. Sometimes the disaster is an act of God, other times it's man-made, but the best of them share this in common. The central characters are faced with difficult, sometimes impossible moral dilemmas. As viewers, we ask ourselves how we would behave in similar circumstances. Could we handle the pressure? Would we make the same choices? Would we do the right thing? Now, some of my favorite disaster stories are about epidemics or disease outbreaks that threaten humanity. Think of Night of the Living Dead, 28 Days Later, 12 Monkeys, or Children of Men, and many others. Now, many of these stories, and in fact the whole zombie genre, were inspired by this book, I Am Legend, by Richard Matheson. Now, the book has been adapted at least 3 times for the big screen, but my favorite version is The Omega Man from 1971, starring Charlton Heston. I love it because it's just so 70s, and Charlton Heston, he just can't stop delivering these cheesy one-liners no matter what happens to him.
He is part of the dead. He has no place here. He has the stink of oil and electrical circuitry about him. He is obsolete. You are discarded. You are the refuse of the past. You're full of crap.
Now, the antagonists in this version are more human than the vampires and the zombies of the other adaptations. And I like that this cult of albino mutants spend all of their time raging against the science and technology that they blame for their fate. Now, most zombie stories, of course, they don't plan on turning people into zombies. It just sort of happens by accident. And usually it's because technology goes a little out of control. Now, as I struggled against my own mob of out-of-control service workers, I began to worry about this risk of technological backlash. Now, as web developers, we're constantly tempted to throw in more and more technology at the problem. But if we're not careful, we risk pissing off our users. Making things that are slow or annoying or insecure, just full of bugs, really risks alienating the people we're trying to make happy. Now, I'm sure some of you are dying to find out what happened. Some of you are dying to see some code. Other of you are probably dying after last night's party. But before we go any further with the rest of the story, we need to take a look at ServiceWorker. What makes it so special, and what makes it so especially dangerous? First, some history. In 2010, as part of HTML5, we got the application cache API, which was a high-level API for declaring which resources should be cached for offline use. By 2014, however, it was clear that the app cache API wasn't low-level enough to be useful, so work began on a new spec called ServiceWorker that would enable more granular control over caching of resources, among other things. A year later, at the beginning of 2015, Chrome 40 and Opera 27 became the first browsers released with basic ServiceWorker support. Now, in the summer of 2015, we were introduced to the concept of progressive web apps. And shortly after came Firefox 44 and Samsung Internet 4, in 2016. And later that same year at Google I/O, in May, ServiceWorker and progressive web apps were put on center stage. Finally, in 2018, the application cache API is being deprecated, and ServiceWorker is due to land in all major browsers with the next releases of Safari and Edge. Very soon, I hope. But what is a service worker anyway? A service worker is a script running in a separate background process that can intercept and modify all network requests made by a web application. Now, service worker, as the name suggests, is a type of worker, similar to a web worker, in that it doesn't have DOM, AJAX, or local storage. It does, however, have post message for communicating with pages and other workers, fetch for contacting the network, and IndexedDB for storage. Now, service worker is a kind of proxy server. It responds to network requests by returning response objects from the network, from cache, or from dynamically generated content. Now, in theory, this means that a web application should be able to function without a network at all. And in practice, having full control over your cache should also improve application startup performance. To make this possible, ServiceWorker has access to new APIs, including Cache API for storing network request response pairs, and a new Clients API for managing connected windows, tabs, and web workers. Now, since ServiceWorker runs in a separate process, independent of the browser, so it runs outside of the browser process, it can do more work than just proxying network requests. It can also respond to push events by receiving and displaying push notifications, and sync events by processing pending network operations that were made while the network was offline. Because they can control several clients at the same time while operating in the background, service workers need to be installed on the device. Now, upgrading remotely installed software while it's running without breaking anything is really, really hard. ServiceWorker is not the web we are used to, but it's probably the web we need. And of course, difficult things are rarely simple. And as you'd expect, ServiceWorker is complex by design. To get from 0 to up and running takes a multi-step life cycle that includes registration, installation, sometimes waiting, and finally activation before your service worker can get ready to do its work. Now, the first step of the service worker lifecycle is registration, which is initiated by the web page when you call Navigator Service Worker Register with a path to your file. Now, once the service worker is eventually up and running, it's going to be able to control all pages that fall under its scope. Now, the scope is determined by where that service worker file is served from, and it can be restricted but not expanded. So in practice, this means that a service worker can only control pages that live at the same or lower level in the directory hierarchy. So that's important. Now, this brings us to our first bug-busting tip. Don't call register while the page is loading. On first visit, it's too late for the service worker to start controlling the page. So there's no point trying to load it before the page itself is loaded. It's only going to slow things down. So you should wait for the window load event or some other signal before calling register. Tip number 2 is don't rename your service worker file. This is extremely important, and it's also a little bit hard to get your head around. But once it's been successfully installed, it's eventually going to need to be updated. Now, if the HTML file that registered the service worker is cached, which is quite common, it's going to be impossible for you to install a new service worker with a different name. So you can avoid this kind of chicken and egg problem by making sure that you never try to rename your service worker file. It should always be a static file name. Now, of course, if the file name is static, if it's never going to change, and the browser was always going to fetch files through the browser cache before going to the network, you're going to have to make sure you set the proper cache control headers to prevent the browser from caching these outdated versions of your ServiceWorker file. Now, as a precaution to avoid accidentally installing a ServiceWorker for days or weeks or months, the browser is automatically going to bypass the cache if the file is older than 24 hours, regardless of what you set. Of course, waiting 24 hours to fix a bug is a painful experience, so do your future self a favor and make sure you set a low expiry. Now, after the script has been successfully registered, the install event is going to be triggered, and the ServiceWorker is going to enter the installation phase. This is generally the best opportunity to begin pre-caching your assets. It's also a good opportunity to talk about promises. Now, the ServiceWorker API takes promise use to new extremes. So using async await can make things much more legible and potentially less error-prone. Now, although browsers only recently began supporting async, all browsers that run ServiceWorker also can handle converting async code to use generators and promises. So you can use Babel with the async to generator plugin to do this transformation with very little overhead. You should also make sure that pre-cached assets can be downloaded, because passing a promise to the event wait until method is going to delay ServiceWorker installation until all those fetches are resolved. However, if it's rejected, if even one asset does not download, the new ServiceWorker is going to be thrown away. So since cache add all is often the easiest way to bulk fetch and add things to the cache, any request is going to cause the ServiceWorker to prevent being installed. So in this sense, pre-cached assets should be considered hard dependencies, so just beware. Now, if there's already an older version installed and running, controlling clients, the ServiceWorker is going to enter what they call the waiting phase until all the clients have been disconnected. Calling skip waiting is going to force the new ServiceWorker to be activated regardless. And it's going to but forcing activation after an update can break all these existing connected clients if the new ServiceWorker behaves very differently than the old one. You should probably avoid calling skip waiting after this major change, and consider prompting the user to trigger a manual refresh instead. So, really easy. All you need to do is listen for a ServiceWorker event update, prompt the user to force the ServiceWorker to skip waiting, and then reload the page when it becomes active. Isn't that really easy? It only took 3 slides. So much easier than calling skip waiting, but much safer. Now, when it's finally safe to begin controlling your clients, the activate event is going to be triggered, and you can clean up old caches before control is finally passed to the new ServiceWorker. Be careful, though. Don't accidentally remove caches that may be used by other applications. So the cache API is origin-based, and it doesn't restrict access based on the scope that you used to register the ServiceWorker. So you should prefix your caches with an application name if you plan on running multiple ServiceWorkers under the same domain. Now, once the ServiceWorker is actively controlling clients, any network requests are going to trigger the fetch event handler, and the ServiceWorker is going to be able to return a response based on URL, headers, cookies, resource type, network conditions, whatever criteria you want. Now, handling the response is going to allow the ServiceWorker to perform runtime caching, but you should always check the OK property of the response object returned from fetch before you add it to your cache, because HTTP response codes don't cause the fetch promise to reject. So you check for 404 and 500, for example. Another thing to avoid is storing global state outside of the event handlers in your ServiceWorker file. Because ServiceWorkers, once they're started, they run that code. But ServiceWorkers are also stopped and started many times over their lifetime. That's to preserve battery and other resources on the device. And that global state is going to be destroyed at unexpected times. So I'm sure all that seems quite straightforward, right? Now I bet you're wondering what the deal was with those zombies. Quite simply, it was part ignorance, part stupidity, and part mystery. In my defense, I don't think it was equal parts, but you can be the judge. It turns out that versions of Chrome before 46 did not support cache at all. So any client missing that API should have caused the promise return to the install event to reject with a syntax error. Undefined is not a function. Now, unfortunately, a catch was also added to the promise chain in order to report install errors. But the error was never thrown further up the chain, and the service worker was installed instead of being thrown away. Now that explains how some clients became infected with a broken service worker. And based on the number of errors reported, you can see that most of them were cleared of their infected service worker, but it's still a mystery as to why or how a small number were cursed and were never able to upgrade to a newer version. It was fortunate that this only affected a small number of older devices, but it's totally unfortunate that this is not the only way you could break your service worker. So let's be honest, cache invalidation is hard. Upgrading software is also hard, and promises are kind of hard also. Naming things is super hard. Service Worker has all of this and more. So what do you do in the event of disaster? If quitting your job is not an option, you might want to buy some time by deploying a suicide service worker that unregisters itself, deletes all caches, and force refreshes all connected clients. If you like your job, you can make sure you don't ship a broken service worker in the first place by testing before you deploy. Now, of course, testing service workers is not trivial, but you can run unit tests in a mock environment with tools like swtest-env, and you can even run a single set of tests on both the command line and in the browser with swtester. Now, I'm not sure I totally trust the organization behind these libraries. I mean, Pope Industries doesn't really sound like even a real company. But there isn't really much else out there today to choose from, so it's definitely better than nothing. Lastly, if you don't want or need to get your hands dirty with the details, you can use one of several tools to help you generate a service worker and manage runtime caching. But you should always test if you can. Even if the details were lost on you, I hope I've at least been able to convince you that service worker should be approached with respect and handled with care. Service worker is awesome, and it lets us do things on the web we have never been able to do before. But it's kind of awesome in the way that a chainsaw is awesome. It's really powerful and a really easy way to lose a hand or a foot or maybe a few toes. But don't be afraid. A lot of people use chainsaws every day without spilling blood. They take precautions, they dress for the job, and they read the instructions. Even disaster stories can have happy endings. Now that I know more, now that I have some tools for testing, I'm not afraid to get back into the lab. And I hope everyone here isn't either, because the web really is much better with Service Worker. Thank you very much. I hope you enjoy the rest of the day.
Good boy, Alexander. Get off the stage.